Hi everyone. In this video, we're going to calculate limits using limit laws. Evaluate the limits of the following. Example A, limit of the function 4x squared as x approaches -1. This is an example of multiplying of constant by a function. In here, we're going to take the limit of the function x squared as x approaches -1. Then after that, we will multiply this with that constant 4. Let us now evaluate the limit by substituting this -1 to the variable x. So we have -1 squared times 4. The square of -1 is +1, and 1 times 4 is 4. This is our final answer. Example B. The limit of the function x raised to 4 plus x squared minus 1 all over x squared plus 5 as x approaches 0. This is an example of division of two functions. So in here, we're going to take the limit of the numerator and the limit of the denominator as x approaches 0 respectively. So we write here the limit of x raised to 4 plus x squared minus 1 as x approaches 0 all over the limit of x squared plus 5 as x approaches 0. Let us evaluate the numerator and denominator respectively. So we have now 0 raised to 4 plus 0 squared minus 1 for numerator. In the denominator, we have 0 squared plus 5. We can simplify this fraction into -1 over 5, and our final answer is -1 over 5. This is example C. The limit of the function 4x squared minus 3 as x approaches -1. This is an example of polynomial function. Let us now evaluate by substituting -1 to the variable x. So we have 4 times -1 squared minus 3. The square of -1 is simply +1. So 1 times 4 minus 3. The product 4 times 1 is simply 4 minus 3, and we have 1 as the final answer. Example D. The limit of the function x squared minus x times the function x squared plus x minus 2 as x approaches 1. This is an example of multiplication of two functions. What we're going to do here is to take the limit of each of the factors. So we have the limit of x squared minus x as x approaches 1 times the limit of the function x squared plus x minus 2 as x approaches 1. Let us now evaluate the limit. Let us substitute the 1 value to all the x respectively. So we have now 1 squared minus 1 times the quantity 1 squared plus 1 minus 2. The 1 squared is simply 1. Also in here, so we have 1 minus 1 times 1 plus 1 minus 2. Simplifying each group, we have 0 times 0, and the final answer is simply 0. Example E. The limit of the function x squared plus 3x minus 16, and this is raised to a power of negative 2 as x approaches 3. This is an example of a power function. To simplify this, we're going to take the limit of the function x squared plus 3x minus 16 as x approaches 3. After that, we will apply the power of negative 2. Evaluating the limit now, let us substitute the value 3 to the x. So we have 3 squared plus 3 times 3 minus 16. And the negative 2 power is here. 3 squared is 9 plus 3 times 3 is 9 minus 16 all raised to negative 2. Simplifying this, we have 2 raised to negative 2. Let us rationalize the negative exponent by simply putting this as 1/2 raised to 2. And this is now equal to 1/4. This is our final answer. Example F. The limit of the function the square root of the quantity 4x squared minus 3 as x approaches negative 2. This is an example of a power function. As you can see, the radical here can be expressed as a fractional exponent. So we have the limit of 4x squared minus 3, and the quantity is raised to 1/2 as x approaches negative 2. Let us take the limit of the function 4x squared minus 3 as x approaches negative 2, and after that, we will implement that exponent 1/2. Evaluating the limit, we have now 4 times the quantity negative 2, that is squared, minus 3. And this quantity is raised to 1/2. The square of negative 2 is 4. So we have 4 times 4 is equal to 16 minus 3. And then the power 1/2 is still here. And 16 minus 3 is 13 raised to 1/2. Putting back this 1/2 exponent into radical form, so we have the square root of 13. This is our final answer. I hope you learned something from this video. See you again next time.